be talking about this lab today, but I will be talking about the lab tomorrow. Today I will be talking about a European project called PRESTO that ended the first semester of this year. This project gathered a lot of partners from all around Europe, and we will focus on a few of them, us, PragmaDev, but also Thales and the University of L'Aquila on the topic I want to address today. So you can find more information on the PRESTO.eu website. So the project objective is described in the very strange acronym for PRESTO, because PRESTO stands for Improvement of Industrial Real-Time Embedded Systems Development Process. So it's something you cannot guess, and even the partners could not remember it. There were different parts in the project, and one of the parts we were working on was on the verification of functional and non-functional properties. And what we wanted to do is first to verify properties on traces coming from real execution. And then the idea came to also verify properties on traces coming from a simulation of a model of the system. So if you look at these triangles with V1, V2, V3, with the requirements, the model, and the traces, we will basically focus on the V3 part to verify the properties. So the first question was, how can we express the properties? There are different technologies available, like for example temporal logic, but that's basically very mathematical. It's very difficult to write. And when you talk to people who write properties, they are usually non-technical people. So it's very complicated for them to use a mathematical tool to express a property. Then you have some more graphical languages like MSC, property sequence chart, and sequence diagrams from URL. And they are very similar. MSC and sequence diagrams are basically equivalent. So you can describe the exchange of information between entities, which is graphically very easy to read. And then property sequence chart added annotations on these diagrams to express the properties. And that's what we have been working on in this project. Because we wanted the traces, the properties, to use the same kind of language. We don't want to use a language for the properties and another one for the traces. We want to use the same one so that it's easy to compare. And in practice, if you have a real execution trace, it's thousands of events, the tool will help you to match the properties on the traces. But at least when you express the properties and when you look at the traces for a human, it's readable and understandable. So what we, PragmaDev is a tool provider, so we had an MSC editor and we had an MSC tracer that could trace execution of a system, like you see here. For example, you have 3 different entities, and the first entity goes to the idle state, the other one to the idle state, and you send information from one to the other, and so on. And you can see a different type of operations like timers, semaphores, messages, and so on. So we started from that diagram, and we thought this was good for trace, but also for specification. Specification is what you expect from the system. But specification is only usually one or a few scenarios. It's not a property yet. Okay? To express a property, you need a way to express causality between events. To be able to say something like, if this happens, then this should not happen. Okay? And what the property sequence chart does is that it adds annotations to the messages. So here you see E, that means if. let's say, if M1 is sent from instance 1 to instance 2, then required M2 should be sent back from instance 2 to instance 1. But if you get M4, then it's a fail. Okay, so actually you have expressed a very basic property in that case. If this happens, then this should happen, or this should not happen. Okay, just with an annotation on the diagram. But actually the property sequence chart is much larger than that. You can express more complex properties. So you'll find the different message annotative prefix I have described here, plus also some constraints you can add to the diagram, and I'll show you an example. It will be much clearer than to try to explain it theoretically. So what we did in the project is, because our previous tracer was not designed to be able to verify properties, we redesigned everything from scratch in the framework of this European project, and we made the tool available for free. So whoever wants to use it and download it, you go to our website and download the tool, and you can describe properties, trace, and verify the properties on the traces. The tool is fairly simple. I mean, its interface is, the main interface is that box, and from there you will be able to edit a new property, start a trace, or read a trace. So when I say start a trace, it's because the tool can read a socket and generate live an execution trace. So the editor needed to be able also to handle very large traces, because when you get a real execution trace, you get sometimes millions of events. So you have to filter out things and collapse instances, erase some type of events and everything. So the editor is also there to simplify the traces you get from execution. So I said one thing about that is, in order to generate the traces, there are several ways. As I said, you can have live traces from a socket, but I mean, if it's a real system executing, because of the real-time issues, might not be very comfortable. So you can also read traces from a file. So it can be either our format or some other formats like the OTF, the Open Trace format, for example. Or it could also be a trace coming from your simulation. So for example, simulation from an SDR model, you can get an execution trace. Then you start the verification, so you have your specification or your properties and your traces, and what you want to do is to verify the properties on the other traces. So you have different level of verification. The first one, the very basic one, is a graphical diff, so it's not very interesting. The second one is specification against trace, so that is a specification without the property sequence chart annotation. And the last one is the most interesting one, is the one with the causality annotation. I'll give you here a few examples. You see on the left property, so that's a property we saw before, that says if I send M1 from instance 1 to instance 2, then I should get M2 back, okay? And if I get M4, it's a fail, it's failure. So if you look at that trace, in which actually we have both cases, the first verification will say, this is fine, that matches the property, okay? And the second one fails. So that's a very basic one. So that's how the tool works. It will display in green, it matches the property, and in red, it doesn't match the property. Another example, a bit more tricky, it says if you have M1 sent from A to B, and this doesn't work anymore. Oh, yeah. That means if you don't have M2 from A to B, then you should have M3. So that's a bit tricky. That means if you have M1 followed by M2 and M3, it doesn't match the property, because there was M2 in between. Okay? Now this one, M1, M4, and M3 matches a property. M1, not followed by M2, followed by M3. Okay, that's just to give you an example of the type of expression you can write in this, with this property sequence chart. So it can be quite tricky, and if the traces are large, then you need a tool to verify it. I mean, you cannot verify it with your eyes. It's not good enough. In this European project, we had several use cases, one from Thales Communication and Security in France, and the other one from Thales in Italy. Both were telecommunication systems. The one in France was a software-defined radio system, and the one in Italy was adult network, mobile adult network. So I'm not very good at this type of telecommunication technologies, but that's the type of traces they get, and you see that the property matrix quite large, and embraces quite a lot of events. So that's the one from Thales in France. They describe some message exchanges between the different entities. And the other one is from Thales in Italy. And it was interesting because these use cases, for example, showed that it was difficult to manage several instances of the same process or of the same class, because when you describe a requirement, you maybe have only one mobile you talk to. Your base station, for example, you talk to one mobile, but actually in reality you're talking to 1,000 mobiles at the same time. But you're not describing all the interactions, you only describe the interaction with only one mobile, but the trace will show 1,000 mobiles. So you have to separate the mobile on which you want to verify the property and do it for all the mobiles. So that was quite a tricky thing to analyze. Actually, I'm done. I'm about the same speed as the...
We got a record there. So we have time for questions.
Yes. So MSC is an ITU.
Thank you.
MSC is an ITU recommendation, right?
Yeah.
And this is an extension, or how can I interpret that?
Today it's the University of L'Aquila has been working with Thales in Italy for quite a number of years, and they ended up with this prefix on the diagrams. So they made up these prefix notations. Now it would be probably a possible extension to the MSc. I have to discuss with the ITU study group to maybe introduce that.
Okay.
But today, no, it's not a standard. No, because I guess it's your question.
Yes.
Yeah.
Yes, I mean, one usual challenge with this MSC formats in testing that I see is that there may be a lot of data coming in these messages. I mean, at least with TTCN3, we've had a lot of challenge to kind of represent that in the MSC. So can you give a few comments about how you handle that in your notation?
Okay, yeah, that's a good question. They all the parameters you can carry when you exchange a message. The thing is that in that project, it was a very high level view. Okay, as you can see, there are very few parameters. And if there are parameters, we just match the value of the parameters. We don't do any symbolic analysis of the messages. Because you could say, for example, if I send a parameter with the value of 4, I should receive the double. And that's what you can do with TTCN3. You cannot do that here. Okay? So it's a higher level view, I would say. TTCN is more in detail. The idea here was to have something easy to take in hand for people who are not technical, because they are the ones who are writing the properties. The TTCN is quite complex.
So what is your target audience or what is the target users for this kind of tooling?
Functional properties. like what the system should do or should not do, maybe for security reasons, focusing on what the system instead of how the system does. You know? Because when you do testing, you're really testing the implementation.
Maybe just one more question regarding more or less the same thing, because what happens if the messages themselves contain data which is essential in the property that you need to describe? For example, the IMSI number, this is the telecommunication thing. The IMSI number is the one where you can separate the mobiles out from each other. How is that handled here then?
Yeah, today it's handled with the value in the diagram of the merge trace of the properties. You have to choose value. You cannot really analyze it like you would do in TTCN and say it has to match this type or this value. Now the thing is that if you look at TTCN, since we have also a TTCN editor and simulator in the tool, what we can do is generate MSC out of TTCN to get a higher view of the TTCN. So if it comes to something that's precise, as you said now, maybe it's better to write it in maybe TTCN if you can express this type of value. But the problem is that if you have execution traces offline, how can you check that? Because TTCN is usually live while the execution of the tester. So with that type of technology, you can take the trace offline and analyze your properties. But as you say, it won't be that precise.
You said in the introduction you want to test functional and non-functional properties, and at the moment I can only see functional things. How do you say, for example, if message 1 comes, message 2 has to come within a certain amount of time, for example?
Yeah,
how do you annotate that?
There is something for that, but it's only about time constraints. That's the only non-functional thing we do. There's nothing about quality or things like that. It's only time. Yeah. We do have that. It's actually in the MSC, in the basic MSC is already there. It's the sequence diagrams as well, so it's in the PSC as well.
All right, a big round of applause for